Today, we want to talk about indeterminate forms. Here are 7 indeterminate forms: 0 divided by 0, infinity divided by infinity, 0 times infinity, infinity minus infinity, 0 to the 0, 1 to the infinity, and infinity to the infinity. So some of these are variations on some rules that we always like to throw out. These are big exceptions, like dividing by 0 is undefined. Except when it's 0 divided by 0, then it's not undefined, it's indeterminate. A bunch of these involve infinity, but we see one of the things that we always say is 0 times anything is 0, which is not always the case. 0 times infinity is indeterminate. You don't just automatically get 0. It depends on the 0 and it depends on the infinity. 0 to the 0 is indeterminate. We've said things before, like anything to the 0 power is 1, and then justify it with some exponents and stuff like that. But we say anything to the 0 power is 1, except for 0. 0 to the 0 is indeterminate. It depends on the 0 as the base, and it depends on the 0 exponent. We also think any power of 1 is just going to be 1. Well, that depends. What if we have an infinite number of 1s? And what if those 1s aren't exactly 1? And then here's another anything to the 0, infinity to the 0. What if we have infinity to the 0 power? Is that still 1? So the reason these are called indeterminate is that we can't give them a value. Undefined means that we cannot give any value. We cannot give any value. Defined means we give something a value. Indeterminate means it depends. So those are your 3 levels. So at the bottom is undefined. Undefined means we cannot assign a value. I mean, technically we can assign a value, but if we assign a value to it, then stuff breaks. That's what I mean when I say we can't assign a value. So when we say 1 divided by 0, we cannot give that a value without breaking stuff. That's like saying you can't attach lasers to a shark's head. I mean, you can, but you can't do that without breaking stuff. See the difference? So undefined means we can't assign a value. It doesn't make sense. It'll cause something to break. Defined, on the other side, we have defined, which means we assign a value, one value. Sometimes we say well-defined. Two plus 3 would be defined to be 5. It's well-defined. 2 plus 3 is 5. So long as we're in a base higher than 6. Or depending how we're going to write 5. In the middle is this indeterminate form. So these indeterminate forms are, it depends on what we're combining. So this is kind of in the middle of undefined and well-defined. So an indeterminate form, it's where it depends on the parts that we're using. Some of these indeterminate forms we've seen before. In particular, this first one, 0 over 0. This was all over at the beginning of the semester, when we wanted to find the slope of the line tangent to a curve at a given point. That was, this 0 over 0 was all over that slope of the line. So this one here, we are familiar with. I was saying once and single. This is the first one that we want to call to because it's the first one that I wrote. I mean, it's the one that we looked at the very beginning of the semester. We want to find the slope of a line tangent to a curve at a single given point. And the whole problem here is that we only have one point to work with. So slope is delta y divided by delta x. But if we only have one point, y2 minus y2 over x2 minus x2, we get 0 over 0. But only in certain cases is this 0 over 0 undefined. Sometimes 0 over 0 is undefined. Sometimes 0 over 0 is 0. Sometimes 0 over 0 is some constant. So the 0 over 0 can be 0 or undefined or any constant in between, positive or negative. So if we imagine this circle, depending on where we draw the tangent of the circle, the slope of that tangent will be 0 or some constant or undefined. There's only 3. It sounded like there was going to be 4. So at this top point, at the very top, the slope of the tangent At that top point on the circle, the slope of the tangent is 0. In that case, 0 divided by 0 equals 0. I mean, not really. After you get through your first calculus class, you can say shit like 0 divided by 0 is sometimes 0. And everybody will know what you mean. So, oh, yes, you are clearly talking about limits. But if this was like an algebra class and you're like, oh, 0 divided by 0 can be 0, then everybody would give you side eyes. We don't trust you saying that. You're not allowed to say that yet. It's like swearing when you're a kid, right? It's like when you turn, I don't know when you were started, when it was allowed for you to be swearing in front of adults and shit like that. I'm sure you swore in front of your friends before that happened. You like test it out in front of adults. I remember when my goddaughter tested it out. I was hanging out with my friends, and my goddaughter was with us, his daughter. She was 12, and she decided to test it out by saying shit in front of us. And we like noticed, but we didn't say anything. I was like, all right, that's okay. You can say that in front of adults now, but only family adults, not like adults out in public. Do you know what I mean? See, there's like levels. And we know that she's been using bad words before now. And that's how she knew about it, because she used it properly in the right context. Like, I can't believe this shit is like that. What? It's an algebra class. I wouldn't say stuff like 0 over 0 is 0. But y'all are sophisticated calculus students now. You understand when I say something like 0 over 0, we're talking about limits. As the numerator approaches 0 and the denominator are approaching 0, then this ratio is approaching 0. We know that's what we mean. We have this intuition about it. Because we know it's not always 0. Notice at this point up in the front of the circle, is this the front of the circle? Doesn't matter. If I draw a tangent line here, then the slope is undefined. In this case, 0 divided by 0 is undefined, whereas at the top of the circle, 0 divided by 0 is equal to 0. I keep saying it. I want to get in trouble. Don't at me in the comments. Because you can't, I turn comments off. So suck it, internet commenters. And then between these points, between the top and the bottom and the two sides of our circle, we can get values in between, positive and negative. So here, we get a slope of positive 1. So in that case, that 0 divided by 0 at that point on the circle is equal to 1. See how dangerous this is? Oh yeah, anything divided by itself is 1, except 0. Because dividing by 0 is not always undefined. Sometimes it's indeterminate. And of course, we can also get negative 1. Or negative values. I already used red. Here, at this point, slope is negative 1. So in that case, 0 divided by 0 is negative 1, which is weird because the zeros don't have any signs. But apparently we've got a positive 0 over a negative 0. So it worked out to be negative 1. Any questions? How's that, okay? Some other places that we've seen indeterminate forms. So this is one from here in Calc 1. Before this, we've seen some infinity over infinity. So for infinity over infinity, for infinity over infinity, we can think about asymptotes of rational functions. A rational function is just a ratio of polynomials. Rational functions are the fractions of the polynomial world. Polynomials are like our whole numbers or our integers. Rational numbers are like our rational functions are like our rational numbers or fractions. When we think about the asymptotes of rational functions, think about the behavior as x goes to positive or negative infinity. Now that we have calculus technology, we can think about the limits. So specifically, I want to think about the limits as x goes to infinity of q of x, or the limits as x goes to negative infinity of q of x. That's our asymptotic behavior, our asymptotes, if we have any. We don't necessarily have. So what we'll see here is when we think about the limit as x goes to infinity of a ratio, if we look at the numerator going to infinity and the denominator going to infinity, we want to see if they balance out at all. So for example, if we look at the limit as x goes to infinity of 5x minus 3 over 2x plus 7. If we think about what's going on with very large values of x, the numerator and denominator are balanced. I have a 5x on top and a 2x on the bottom. So for very large values of x, the only thing that matters is the 5x, and for very large values of x and the denominator, the only thing that matters is the 2x. So here, as x goes to infinity, the numerator goes to infinity and the denominator is going to infinity, but they're kind of going to infinity at the same ratio. So we see that the numerator, this is going to infinity. And the denominator is also going to infinity. So we have this indeterminate form. But we know we can think our way through this problem. We think for very large values of x, first of all, the subtracting 3 doesn't matter. Like if you walk to the lottery office because you won $5 billion in the lottery and you walk out with a big bag of cash and $3 falls out, you're not even going to notice. You're not even going to notice. You're not going to worry about the fact that you spent $3 on buying the tickets because you just won $5 billion. So you're not going to be like, oh, I have $5 billion. And someone's going to be like, oh, but you spent $3 on the ticket, so you're not as rich as you thought you were. At which point you just pull out a big wad of bills and throw it at them because it's $5 billion. And you shouldn't care. If you do care about like a handful of bills from a bag of $5 billion, if you do care, you're not responsible or knowledgeable enough to have that kind of money. and we collectively need to take it away from you. Do you know what I mean? That's a lot. Like if you've got $5 and I ask for $3, that's a lot. You got to be like, oh, hang on, man. If I give you $3 out of my $5 only, or even if you had $50, asking for $3 is a lot. If you have $5 billion, asking for $3 is nothing. Similarly, if you won $2 million, say, oh, here's some $7 extra, that won't matter. So really what we're looking at here for large values of x, the only thing we care about is 5x on top and 2x on the bottom. That's how we think about this limit and come up with 5/2. Forget the -3, forget the +7. These are pretty much the same order of magnitude. Top and bottom have the same order of magnitude. In this case, infinity divided by infinity is 5/2. So we think of them as balancing out. One dude has $5 billion, the other dude has $2 billion. They high five each other and say, we are billionaires. And then maybe secretly the 5 billion billionaire says, that poor, he's only got $2 billion. So this is a case where infinity divided by infinity is some constant. Indeterminate, in this case, is some number. If we have a different limit, once again, the numerator is going to infinity, the denominator is going to infinity, but the numerator is going to infinity at an order of magnitude faster than the denominator. So the numerator is going to infinity. This is still an infinity divided by infinity situation. But in this case, we can see that the numerator is winning. For large values of x, 2x is nothing compared to 5x squared. For large values of x, 2x does not matter when compared to 5x squared. Once again, we can see that the -3 and the +7, those aren't going to matter for large values of x. For small values of x, like 0.01, yeah, 3 and 7, those are a big deal. But for large values of x, 3 and 7 don't matter. And for large values of x doesn't matter compared to x squared. If x is 1,000,000, that's a 10 to the 6th. X squared is 10 to the 12th. That's a million. If you have a million, a million is nothing. So this limit doesn't exist. This limit goes to infinity. The numerator has a greater order of magnitude. So it's going to infinity faster than the denominator. That's the way we're thinking about it. We can think of this as the top going to infinity faster. In this case, infinity divided by infinity doesn't exist, it's just infinity. I guess if the denominator wants to get revenge, we could just change the sign. I'm going to change the numerator. Because I made the numerator the -1. Most importantly, the limit still doesn't exist because this value is headed towards negative infinity. But since we played an Uno reverse card on the top, we're going to negative infinity instead of positive infinity. In either case, the limit doesn't exist. We're just being descriptive about how it doesn't exist. And of course, if we flip the whole thing over, put the square in the denominator, then the denominator is going to infinity faster than the numerator. And so the limit will equal 0. We're back to the limit existing, and the limit will equal 0. That's another indeterminate form, where infinity over infinity is something else. So once again, we've got an infinity over infinity. But in this case, we're back to having a limit. The denominator is going to infinity faster. We're dividing by infinity. That's going to go to 0. Remember, when we're talking about limits, we're not saying that infinity divided by infinity is 0, even though we're going to be casual about it and be cool and say things like infinity divided by infinity is 0. And then if like trig students start saying that shit, we're like, you don't get to say that. We're calculus students. We can say shit like infinity divided by infinity is 0 in this case. We know that we need that there is some m such that if x is greater than that m, we can make this fraction as close to 0 as we want. We can eventually make this fraction as close to 0 as we want. We just have to find an x that's large enough. So always remember what we mean when we talk about limits at infinity. That's even pretty sloppy right there. I just said limit at infinity. Infinity isn't a place. Limits approaching infinity. When we're dealing with limits approaching infinity, this means that we can make the fraction as close to 0 as we like, That's the epsilon. So long as x is sufficiently large. This is just the limit at infinity version of the epsilon delta definition. When we say limit as x approaches c of f of x equals L, we mean we can make f of x as close to L as we like, so long as x is sufficiently close to c. When we have dealing with infinity, we can make the expression sufficient as close to 0 as we like, so long as x is made sufficiently large. And then beyond that value of x, the fraction will always be as close to 0 as we like, within epsilon of 0. And then, because we're sophisticated calculus students, we can get away with saying, in this case, infinity divided by infinity is 0, because the bottom infinity is bigger. Even though that's an incredibly sloppy way of saying it. Any questions? It's difficult because we got to navigate all this math stuff through the language of, well, I'm using English, but like a spoken language. And spoken language is always worse than math for communicating math ideas. Because spoken language has all kinds of baggage attached to it. Like when a student says, can I go to the bathroom? And the teacher's like, well, I don't know, can you? I mean, you know what they meant. Don't be a dick. You know what they meant. That means, may I go to the bathroom? It's how we ask it. It's English. Grow up. I'm talking to the teacher. Teacher, grow up. If I was braver, the best thing to do, if you're like, well, can I go to the bathroom? If you have one of those teachers, first of all, that'd be weird because you're all college students now, but can I go to the bathroom? Tell your little brother to do this. And if the teacher's like, well, I don't know, can you? Have your little brother sit there and pause, go, and then go, yes, I can. And then when they're not looking, pour water into their lap. They should just pour water into their lap. And then when they're walking out, it's like, oh, maybe don't be so pedantic next time, because you know what I meant. You know what I mean? If you know what the person meant, then the communication was successful. And if you start picking it apart, you're being a dick. Anyway, we're going to be casual and say stuff like, in this case, infinity divided by infinity is 0. Because we're talking about indeterminate forms, and we're sophisticated calculus students, and we know what I mean when I say 1 divided by 0 is infinity. We know that if we take this, that this value of this fraction, it can be as close to 0 as we want, so long as we make the denominator sufficiently large. Question? Yeah. What's that? Oh, epsilon. That's the epsilon from the epsilon delta definition of a limit. When we say for, limit as x approaches c of f of x equals L, if and only if for every positive epsilon, there's a positive delta, such that absolute value of x minus c less than delta implies the absolute value of f of x minus L is less than epsilon. That was the definition of the limit before we started being kind of casual about limits. So I see where this is going without having to prove where this is going. So these are all indeterminate forms. We're refining what we mean when we talk about defined versus undefined. This is kind of one way to think about it is a middle ground between defined, 2 plus 3 is 5, versus undefined, 1 divided by 0 is undefined. It kind of solidifies what we mean when we say undefined. Undefined means it can't be defined. We can't say that 1 divided by 0 is some value. We can't even say something like 1 divided by 0 is infinity, because sometimes 1 divided by 0 is negative infinity. So it just doesn't work. We're not giving a number. Indeterminate means it depends. So that's kind of like the scale, the hierarchy of defining stuff. Any questions? How's everybody okay? Everybody looks stunned. This is always what happens when I can't be here on a Thursday, but then I come back on Friday. I just get a half of a room full of people being, dude, you should have just bailed on Friday too. Well, that doesn't make any sense at all. Like when Thanksgiving rolls around, we're gonna have Thursday and Friday off, and people be like, oh, we should just have Monday, Tuesday, and Wednesday off. It's like, well, that's like 60%. That's like if like you're driving along and you get distracted and like two wheels on your passenger side like go onto the little bumps on the side of the road. And it's like, oh well, I might as well just drive my car into the ditch now. That's like bailing on Monday, Tuesday, and Wednesday of Thanksgiving. If anything, we should cram more shit into Monday, Tuesday, and Wednesday because we've only got 60% of the days. But it's like, oh, we should just give up. I'm just gonna drive my car into the ditch. But anyway, that's fine. It's fair. I canceled kind of very late, so I can understand taking revenge today. It's like, oh, screw you, Leach. I'm not showing up on Friday. I'm gonna pretend to log into the Zoom because they're on the Zoom right now, but they're like, I logged into the Zoom, but I'm not paying attention. I'm gonna go make myself a sandwich or a coffee. I can tell because I'm gonna end the Zoom and they're still gonna be logged in. I can always tell. All right, that's going to do it for today. I will see. That's going to do it for this week. I will see you all on Monday. Everybody have a good weekend. And thanks for playing.